Hello students, this is lesson U1A00. By the end of the lesson, you should be able to say I can classify numbers and apply order of operations. So let's take a look. Now students, I know this is probably not the first time that you're hearing or seeing a lesson on classification of numbers or a lesson on orders of operation. However, I will say this, it is really important to talk about this at the very beginning of an algebra course, simply because these are the fundamentals. These are the building blocks to which all other concepts are going to be based off of. So much like the axioms in geometry, such as a straight line, a line can be drawn between 2 points, that all distances between the point and the center of a circle is called the radius. The axioms of geometry is the building block of geometry. Right? So for algebra, numbers and our understanding of numbers is the building blocks. So let's take a look. So at the time of this recording, my daughter is 3 years and 10 months. She's going to be turning 4 in August. So, and I'm using her as an example because even at this very, very early age, she learned to count. I would say maybe around 1, maybe 2, something like that, where she's able to grasp basic concepts of, counting 1 block, 2 block, 3 blocks. For this reason, we say that math is actually in every one of us. We innately understand how to count, which is why these counting numbers, okay, are given a special category, a special set. We usually refer to numbers ranging from 1 to infinity, all of these whole numbers, okay, we refer to them as natural numbers. And why are we calling them natural numbers? Well, that's because these numbers, okay, occur to us naturally. We understand there's 1 item, 2 item, 3 item, 4 items, right? And then with our maturity, okay, and I'm sure as you guys mature, that you guys have a better grasp of the sense of the world around you, the next concept is, well, there's actually such a thing as zero. And actually, it took humans many generations to develop this understanding. Having this understanding of a zero was a huge leap in our development. I mean, Roman numerals doesn't have this concept of zero, right? So it actually took us a long time to understand that zero is actually vital to our understanding of the world around us and how we can account for things. So, which is why then, after we understand, like, oh, zero is actually a vital part of the number system, we gave that a new classification. We call this number set whole numbers. So any whole number including zero, we classify that as whole numbers. Integers, okay, was our next iteration in our human development, okay? So not only are we able to account for positive things, but we're also able to account for negative things. And this gave way to exchange, free markets, right? We are able to exchange one item for another, but then we realize, wait a minute, in that exchange, somehow the value isn't quite balanced, right? And then this concept of negative comes into place. So integers is actually a really important part, again, in our maturity, in our understanding, in our development, in human evolution, okay? After having this understanding of integers, then our maturity continues to progress, okay, and we are able to understand that, well, actually, there are numbers within numbers. There are numbers in between numbers, rather, not within. There are numbers in between different numbers, and hence we come up with this concept of rational numbers. And rational numbers, okay, are numbers that have terminating zeros or have decimals that are forever repeating. Why does it have that kind of definition? And why is it well, let's start there. Why does it have this definition that it's terminating zeros? Well, that's because rational numbers are thought of as fractions. Okay, and this is actually a better way of thinking about it than describing it as a rational number. A rational number is in fact a fraction. So any fraction, okay, that you write, okay, where the numerator and denominator are integers rather, okay, with the exclusion that the denominator is 0, this is going to be a rational number. And then later on, we figured out that, wait a minute, these fractions, okay, as it turns out, are not the only numbers in between these sets of numbers, but we can have what's called irrational numbers. And these irrational numbers are numbers that cannot be expressed as fractions, yet they do have a place in this understanding of the number line. So our understanding, our maturity of numbers, as you can see, we start off with rational numbers, and then they progressively get more and more abstract. Okay? So we have this understanding of all of these numbers, okay, that are existing on the that are on this number line, and then philosophers, mathematicians then said, wait a minute, all of these things are really a part of what we call the real number. Okay, so a real number, okay, are numbers that include rational and irrational numbers. So, and then that doesn't really stop there, because with more development, with our understanding of the world, our physical world, and then the world in which we create, it's in particular like engineering concepts, okay, in particular whenever we work with electricity, okay, and anything involving computers, this concept of imaginary numbers come in even also very, very handy. Okay, and what exactly are imaginary numbers? Imaginary numbers are numbers that have a factor of square root of -1. I'm not going to get into too much detail of this because this is very abstract, especially for this introductory video, but understand that with our maturity, with our understanding, okay, we then have this understanding that imaginary numbers are these numbers that have a factor of square root of -1. And then lastly, for at least high school, for high school algebra, okay, the last classification of numbers is this idea of a complex number. And what exactly is a complex number? A complex number is a number where it has a real number and a imaginary number added together. So that's a complex number. And if we take a look at all the number sets that we have really two different kinds. We have a real number system, and then as well as an imaginary number system. And it can all be classified under this one Venn diagram, okay, under numbers. So we have the real on the left and then the imaginary on the right. So the imaginary numbers, okay, again, are numbers that involve square root of -1, and a complex number are numbers that involve a real plus an imaginary number there. So again, this Venn diagram isn't anything new. You've probably seen this again, but again, any legitimate algebra course, okay, it is necessary to talk about these concepts before we dive into anything else that is more higher level. Continuing on, so after our in this development in understanding numbers, well, how do we then work with these numbers? That's where operations come in. So the again, speaking on behalf of my daughter, who is, again, turning 4 in 2 months at the time of this video was made, she understands very, very basic concepts of addition. That if you have, let's say, 2 ice cream pops, okay, and mommy and daddy each has 1 ice cream pop, we have a total of 4 ice cream pops, right? So this concept of addition, more likely than not, was one of the first operations that as humans were able to develop. Well, with any operation, there is a way to undo that operation. So to undo the operation, we are going to perform a subtraction. And then with more abstract, higher level understanding, okay, well, are there shortcuts to adding things? Most certainly. The shortcuts to adding things, okay, or repetition of addition turns into multiplication. And then how do we undo this concept of multiplication? Well, that turns into division. And then yet our maturity and understanding of these operations mature a little more, okay? Are there repetitions of this operation of multiplication? As a matter of fact, there is, and we refer to that as exponents. And then how do we undo exponents? This is something new that you're going to study in this course. To undo this last operation, we're going to have to perform something called a logarithm. So if you look at this, okay, this chain of operation, it makes sense. Can you see why, if we were to perform the operation 2 times 3, if we were to perform the operation 2 times 3 to the 4th, why we must first evaluate 3 to the 4th and not 2 times 3? Right? Pause the video to see if you can answer that question. So welcome back. Hopefully you guys had a chance to think about this, right? We wouldn't do 2 times 3 first, because if you look at this, the exponent, 3 to the 4th, is way on the end. It's way on the end of the order of operation. This right here, this operation right here includes all of the multiplication and addition that took place before it. So, which is why this last operation here will take precedence. It will have to happen first before the multiplication. And then similarly, can you see why we have to, again, perform the exponent before the addition? It's pretty much for the same exact reason, right? Because of the fact we are so far down the orders of operation there, we have to perform that first before we can do the lesser ladder of operations. Okay, so with that said, to keep things simple in mind, right? Because looking at this graphic, it's really hard to keep things straight in your minds, which is why a lot of times in elementary school education, in junior high school education, and even high school education, teachers tell you this right off the bat. Well, to keep things straight in your heads, kids, right? Even though we have the understanding that addition and subtraction, right, takes no particular order. Multiplication and division takes no particular order. Exponents and logarithms takes no particular order. However, okay, if you were presented multiplication, division before addition and subtraction, you have to perform the multiplication and division first. To keep things straight in your heads like this, okay, without having to, have this graphic in place all the time. Another way of thinking about it, okay, there's this handy dandy acronym that every math student is familiar with, and that is this idea of Pemdas. So what does Pemdas mean exactly? Well, Pemdas just means you take the what's being grouped first, okay? That's the parentheses, and then you're going to solve the exponent aspect of it, and then multiplication and division, and then addition and subtraction. Understanding that multiplication and division, it could be of either order. Same thing with addition and subtraction. It could be of either order. Okay, so again, this idea of parentheses, though, I haven't really touched upon. Parentheses is used for grouping. Okay, if you can see here in this graphic over here on the left, that these operations are actually quote unquote grouped. If you think about it, right? We first start off with addition and subtraction, moving on to a higher level, like repetition of those operations. We turn into multiplication and division, and so on and so forth. We are grouping these operations here. So another way of grouping operations is through the use of parentheses. Well, as it turns out, okay, a fraction bar is actually an implicit way of grouping things. So a fraction bar, okay, actually groups the numerators differently from the denominator. It separates them out. So in practical terms, okay, a fraction bar is actually interpreted very much like a parentheses. Okay, so keep that in mind as you go through the different exercises in this lesson. All right.